Hello friends, welcome to my channel. So today's video is going to be one of the most important videos of this playlist. So in today's video tutorial, we will learn how to attach a vector DB with your LLM application and how to store data into it and how to retrieve data out of it. So first of all, it is important to understand why we need a vector DB at all when our LLM is already trained and can answer perfectly. So the thing is that LLMs are trained on public data only. Now, if you want to develop an LLM based application which is specific to your business or say some personality, then no LLM will be there to help you directly because all of this content is private. For example, if you are creating an AI trainer for an institution, then you will want to use their video tutorials as your base. We can still use the ability of LLM to understand the text and retrieve relevant information as response out of it, but we will need to support it with a specific document or text to give it a context. This is where vector DB is used. In today's video, we will use one of the very famous YouTuber, Ali Abdal. We will start by uploading the transcripts of some of his videos and then try to ask questions to our application and see if it responds in the way Ali would have. So first of all, let me just show you how I am taking the transcripts of Ali Abdal's videos. So this is one of the videos of Ali Abdal. What I can quickly do is I can copy this URL. I can go to youtubetranscript.com and I can simply paste this URL here and convert his video into text. So this is how I can generate the transcripts of his various videos. For this video tutorial purpose, I have converted 6 of his videos. I have created the transcripts of those 6 videos, and then we will be uploading these text into our database. So let's start with the programming. So our tutorial or this application will be splitted into 2 parts. One process which will be create db.py will be to create a database and upload text into that database, and then there will be one application which will have the front end, and that will extract the information, that will take the user input, and based on that user input it will extract the information, prepare the response, and then it will show the response. So first of all, we will create the backend Python program which will basically upload the data into our vector db. So what will be the architecture of this create db.py? So for data storage in vectordb, we have our documents stored in a document directory. We will be using the document loader feature of Langchain to load all of those documents into our application, and then we will perform certain transformations which includes text splitter and len function to help the text splitter only, based on which we will be splitting our text. Consider it that one transcript or one document can have thousands of characters into it, but we may not want to store it as is for as is in the vector db, because then it will decrease the performance of the vector db. So that's why we want to split our text into chunks and then store those chunks into the vector db and then perform our search based on those chunks only. So this splitter functionality will convert the complete document into chunks, and then we will further perform embedding. So embedding is basically nothing but converting a text into numbers so that whenever we perform a simple search, we can use faster matching criteria based on numbers, and then we can extract the data in a faster mode. And then we will upload or store this document into vectordb. Let us go to the program now. So first of all, we will need to install libraries which is Langchain, OpenAI, Streamlit. We will be using Fast Vector DB which is provided by Facebook. So we will need to install Fast CPU, and we will need tick token. Tick token is basically an encoder which is used by GPT model to calculate the number of tokens. For example, if I show you, so this is the token, or this is the encoding which is used for GPT 3.5 Turbo. So what does it mean to calculate the tokens is, let's say I write a word here which is physics. You can see that it has 7 characters and it has been calculated as single token only. But if I write it in another format, or let's say in uppercase, you can see that the same word in the upper case, again 7 characters, but now it has been calculated as 3 tokens. So this basically is an encoder which identifies how my characters or how my text will be divided into tokens. Why this is important? Because GPT model calculates the tokens instead of characters or instead of text. So, and it has a limit. So if we go to GPT 3.5, it has a limit of 4096 tokens which it can process in a single call. Now it includes input as well as output. So we may not want to pass, let's say, 4000 tokens to it, so that it does not have any bandwidth or uh, any tokens left to include as its response. So that's where this token tick token function will be helpful. So I will explain it. So after that, we will import various classes. Uh, we will import OS to set up our environment variable. App secrets will be having my OpenAI API key. Embeddings, we will need to embed our text. Tick token, we will need to calculate the or convert the text into tokens. Document loader is to load documents from a directory. Text splitter is to split the text into various chunks. This library we are loading because we need to deal with various paths like root path, and where we are storing our database, and where our prompts are stored. Text loader is a class. This is basically while loading the documents, uh, a document loader or directory loader can load different types of document, but we want to give or specify a specific class based on which it should load the documents. And then we will be using faz as our vector store. So first of all, we will have to create the OS environment variable for our OpenAI API key. Then we are creating a tokenizer with the help of tick token.get encoding. So this is the encoding model, and we are creating a tokenizer based on this model only, so that our model for the LLM and the model or the encoding for the text is same. This is a simple function which takes text as an input and calculates how many tokens it will be converted into. So tokenizer.encode text, it will convert the text into tokens, and then simply we are returning the length of the tokens or how many tokens it has been converted into. So these are some paths, root path for our project. Doc path is where we are storing our documents into docs, Ali Abdal transcripts, and then DB path where we are going to store our database. Right now, there is nothing in our DB. Yeah, it is empty. So as a next step, we will be loading our documents. So we are creating an instance of directory loader by giving the path. Globe parameter or argument defines what is the pattern matching for the files. So we can have multiple files in that directory, but if we want to load only files identified with a specific pattern, then we can use that pattern here. And then we are defining a loader class. This specifically helps to identify the encoding. If you are not using it, you may get into like UTF-8 encoder error. And then we are simply loading the docs into our docs variable, all the documents. And here we are printing how many documents we have loaded. So as the next step, we are creating an instance of splitter. We are using recursive character text splitter. There are multiple types of splitters you can use. So we are defining a chunk size of 400 and chunk overlap of 20. Now what does it mean? So chunk size is, let's say this is one of our transcript. Let's say from here till here, I count as 400 chunks. Okay. So this will be my first chunk. From here to here, I count the second chunk. So this will be my second chunk. So that's how this whole document will be converted into chunks, and chunks will be a list. Now, the second argument which we are passing is chunk overlap 20. This is very important because now when we are breaking the complete text into smaller text parts, we may lose the context, or we may lose the way how two chunks should be connected, or what was the previous context, right? So to support that, what we are doing is, when we are creating the second chunk, we are using the last 20 tokens of the first chunk and merging it here. Now we may have, when we are creating chunks like that, for every chunk we may have, or we will have a small context which will relate it to the previous chunk as well, and in that way, if we want to create the whole document, we will be able to combine based on the context and serialize the chunks. So that's where the chunk overlap helps. So if you do use chunk overlap equals to 0, it will simply do not overlap any text within chunks. It will be like that only. Now length function we are using to identify that each of our chunk which is created is of this length 400, and these are separators. These are default separators for this function. You can give more as per your requirement, but this goes in priority that first of all it will try to split text using double carriage. If it does not find a suitable splitter at the double carriage, then it will use single carriage to split the text so that it can get the appropriate size of the chunk. If that is also not possible, then it will use space, and if that is also not possible, then it will use anything to split the text so that it can create the chunks of this size. It will not always be 400, it will be somewhere near to it, like let's say 396 or 390 or 395, based on where it find one of these splitters. So in the next step, we have used this instance of splitter to split the text. We have passed our documents which we have uploaded. Here I am just printing the length of the chunk and one of the chunk, which is very first chunk. And then we are simply creating a vector DB using the chunks which we have created and using the embedding. So intermediate step will be that it will take our chunks, apply the embedding, and then store that embedding into our vector DB. And then we are simply storing this vector DB into our local directory path. So if I run this program, python create db.py. Okay. So total docs it had loaded is 6. So when you are loading PDF, it may not always be equal to the number of files you are loading. It may go up and down. So we are good with that. These 6 documents got converted into 82 chunks. Remember that we converted our text into chunks of 400 tokens each. And this is our first token. So this will be the format that it will have a page content, and it will also have a metadata which will have the information like what was the source from which this chunk was extracted. If I simply take this chunk from here to here, copy this, and then paste it here, you can see that the token length is 400. Here it is matching exactly, but you may see cases where it is not 100% matching. It may be like 2 or 5 tokens less. So that's how we converted our complete text into 82 chunks and then loaded into our database. Now, if you go to the database directory, db Ali Abdal transcripts, you can see that 2 files has been created, index.faiss and index.pkl. So this is the database which we will be using in our next Python file or application. So let us go to the next application. So this application or this Python program is to basically read the data from the database based on the user input. So the architecture of this Python program is, for data retrieval from vector DB, is that user will give us some question. We will send this question as a step 1 to the vector DB. Based on the similarity search, we will extract some specific chunks. Now, in the next step, we will pass these extracted chunks and the user question to our LLM to prepare an answer based on this question and on these supportive documents. And then prompt will revert a final output to us. So let us develop this program now. So these are the libraries, all are same. So, so first of all, we will have to create the environment variable for our OpenAI API key, because we will be using OpenAI LLM. This is again root path, DB path. We are using Streamlit to create our front end. So we are giving it a title vector DB demo. You can give any creative title to it. And then we are taking one user input from it. In the next step, we are loading the database by giving the path. Here also we will have to provide the type of embedding, because based on that it will perform the searches. And then we are using a prompt template. Now prompt is very important here. So we have used the load prompt class of Langchain to load our prompt from a prompt JSON file. So if I show you my prompt JSON file, you can see that I have defined a prompt here. I have defined the variables here. And instead of defining the prompt template, I am saying pick up the text from a text file, which is prompt underscore template dot text. Now this is simply easing out how I will maintain the code versioning in real application development scenario. So if you go to my prompt template.txt, this is simply nothing but a text. It defines, or it creates a persona of my LLM, saying that you are Ali Abdal, you are a YouTuber, podcaster and writer based on London, who shares strategies and tools for career counseling and making standout resumes. So this is basically defining a persona for my LLM, so that while responding to the user question, my LLM knows what is its persona and what should be the context. Here I am passing the supportive documents. Prepare your response based on below text only. So this is very important, that I am passing my supportive documents, and then I am passing the user question with the variable user prompt, and then the response by the AI. So that's how I am preparing my prompt. In the next step, I am simply creating an instance of LLM, and then if my user prompt is received, then first of all I am searching using vector db.similarity search function. I am passing my user prompt. So basically, passing my user prompt, I am identifying which chunks are similar to my question and then uploading them into docs. uh, by default it uploads 4 chunks. You can increase and decrease the size of the chunks based on the size of the chunks in token. For example, as I said, that we do not want to go input token size of greater than, let's say, 2000, because then rest of the 2000 we are leaving for LLM to prepare and response back, right? So depending, if your chunk size is 200, you can increase this count 4 to 10, and in my case it is 400, so I am keeping it 4 only. So it will be 1600 tokens. And then in the final prompt, I'm based on this docs and the user prompt, I'm preparing my final prompt. And then I am using the LLM by passing the final prompt to predict the answer. In the output final case, I am printing that output which LLM provides to me. And just to showcase you how or what are the documents which are extracted from the vector DB, I am also printing the documents which are extracted into an expander. So now we can simply run this application. To run this Streamlit application, we will need to type Streamlit run and then file name. Okay, our application is running. So far so good. So Here I have uploaded the videos which support how to convert your hobbies into your profession. So let's ask the questions in the same context. Hi Ali, is it a good idea to make your hobby into your profession? My application is running. Okay, so guys, it may take some time depending on how much data it needs to extract from the database, because there are input output operations involved. So usually it may take some time. So my response from Ali is, making your hobby into a profession can be a great idea, but it has its pros and cons. It can be a great way to make money and turn something you love into a career. However, it can also be a lot of hard work and require you to put an extra effort to make it successful. So now you can see that I am getting the response as my application is a true Ali Abdal, and how he would have responded, my application is responding in the same way. So if you want to see what documents which were extracted from my vector DB, so you can see that total of 4, 0, 1, 2, 3, 4 chunks were extracted, and then these chunks were passed to my LLM, and my LLM finally prepared a response based on my question and based on these documents only. So if I go and type another question, hi Ali, can you give me step by step plan to make my hobby into my profession? So let's see. Okay. So yes, absolutely. The first step is to identify the problem or need that your hobby could solve. Then figure out how you can monetize your hobby by providing a service that helps to solve the problem or need. Think of the ways to combine different interests to create a unique offering and build an audience who is willing to pay for it. So now you can see that it is giving me a short plan. I can also type that give me a detailed or long answer uh, as a plan, so I can use that plan to convert my hobby into my profession. Accordingly it will respond, but I in my prompt I have specifically mentioned then try to keep answers as short as possible. So again we can see that 4 chunks were extracted based on our question, and those 4 were passed to the LLM to prepare its answer. So that's how you can create a real world application which can mimic a person or which can mimic a non-existing person even. For example, you want to create an AI HR for your organization who can give answers to the employees and their questions based on HR policies. So you can develop such applications. And this is all for this video, guys. And if you find this video helpful, please like it and subscribe to my channel. Thank you and see you in the next video.